On the 20th of February, 1943, just north of Tunisia's Kasserine Pass, a spectacle unfolded that would forever defy the neat columns of official battle reports, a scene that German tank commanders watched with a growing sense of disbelief. They witnessed American Sherman tanks moving with a precision that shattered every established principle of Wehrmacht doctrine, executing complex maneuvers seemingly without any visual signals whatsoever. Amidst the swirling dust and thick smoke of the North African desert, 5 Shermans, geographically isolated from one another by the rugged, broken terrain with no possible line of sight, converged upon German positions with a synchronicity that felt almost preternatural. There were no fluttering flags, no brilliant flares arcing through the sky, no dispatch riders braving the chaos between the steel beasts. And yet they flowed across the battlefield as if they were a single, interconnected organism, each tank instinctively covering the unseen blind spots of its brethren. Every crew possessing an uncanny awareness of their comrade's exact location. Inside their Panzers, equipped with the standard WWII radios, German commanders strained to decipher the orders of their own company leaders through a crushing wall of static that rendered their amplitude modulation systems nearly useless. The 10-watt German transmitters, which had been the pinnacle of technology in the 1930s, could barely push a signal a few hundred meters once the tanks were in motion, their engines roaring. A vast number of German tanks were tragically fitted only with receivers, leaving their crews mute spectators, unable to report enemy movements, unable to cry out for desperately needed support. The Americans, however, were wielding a technology so advanced the Germans were not even aware of its existence. In every single one of their tanks hummed a frequency modulation radio, a marvel of crystal-controlled precision, boasting 25 watts of raw transmission power, delivering a clarity that sliced through the cacophony of engines and the pandemonium of battle as cleanly as a surgeon's scalpel through tissue. 8,000 miles from the humming assembly lines of Detroit, the most pivotal technological superiority of the Second World War was making its thunderous debut, not in the thickness of a tank's armor or the caliber of its gun, but in the silent, invisible electromagnetic waves that wove every American tank crew into a cohesive fighting force, a network the Wehrmacht could never have conceived. This revolution had its genesis on the 22nd of July, 1941, the day the United States Army officially standardized the Signal Corps radio sets SCR 508, SCR 528, and SCR 538 for installation in all its medium tanks. Even as German forces were storming across the Soviet Union, employing tactics heavily reliant on radio links between command vehicles, American engineers at the Galvin Manufacturing Company, the firm that would one day be known as Motorola, were busy perfecting the very frequency modulation technology that would soon render those German systems utterly obsolete. The brilliant engineering team included Daniel E. Noble, the visionary who first imagined the application of FM technology within the unforgiving environment of military vehicles, and Henryk Machnewski, the lead RF engineer, who ingeniously solved the myriad technical puzzles of embedding such delicate electronics into the brutal, vibrating world of a tank. Their creation, a robust 181-pound unit, magically transformed every Sherman tank into an active node within the world's very first mobile battlefield network. The BC-604 transmitter, a core component pulsed with 25 watts of power, a staggering 2.5 times the output of its German counterpart, the Fuge G5. It operated within the 20.0 to 27.9 MHz frequency band, offering 10 preset channels locked in with the unwavering stability of crystal control. The innovative dual BC-603 receivers integrated into the SCR 508 system granted commanders the game-changing ability to monitor multiple frequencies at once, a feature that would repeatedly prove decisive in the heat of combat. The true paradigm shift, however, was frequency modulation itself. Edwin Armstrong's revolutionary FM technology, licensed to the military, simply erased the static and interference that perpetually tormented amplitude modulation systems. While German tank radios helplessly picked up every stray electrical discharge as disruptive noise, American FM radios delivered crisp, clear voice communication, even amidst the deafening roar of an artillery barrage. On the 8th of November, 1942, Operation Torch ferried American armor onto the shores of North Africa. The tanks of the 2nd Armored Division, rolling onto the beaches near Safi and Fadala, carried with them the SCR-508 radios that would soon unequivocally prove their dominance over German communications. The famed Afrika Korps, despite being the Wehrmacht's most seasoned and battle-hardened armored force, found itself hamstrung by profound communication constraints. A typical German tank platoon consisted of 5 vehicles, but of these, only 1 or 2 were equipped with the full FUG-5 transceiver capable of both sending and receiving messages. The rest of the tanks were fitted only with FUG-2 receivers, leaving them as passive listeners who could hear orders but could never respond, never report, never share vital intelligence about enemy dispositions. Consequently, a German tank platoon operated within a rigid, inflexible hierarchy. The platoon leader would issue commands, and his subordinates would acknowledge them through their actions, not with their words. This created a critical single point of failure. Once the command tanks, easily identifiable by their multiple antennas, were located and destroyed, entire platoons would devolve into uncoordinated chaos. This inherent weakness would prove to be utterly catastrophic when pitted against American forces, where every single tank possessed the latent ability to assume command functions at a moment's notice. The Battle of Kasserine Pass, which raged from the 14th to the 24th of February 1943, served as the first large-scale, undeniable demonstration of America's radio supremacy. Although the battle is often recorded as a tactical victory for the Germans, it simultaneously unveiled American capabilities that left Wehrmacht observers completely stunned. Throughout the confused, swirling engagements of the battle, scattered and isolated elements of the U.S. 1st Armored Division seamlessly maintained their coordination across a sprawling 50-mile battlefield. Tank crews who had never laid eyes on each other before orchestrated intricate attacks, relayed urgent warnings of impending threats, and summoned devastating artillery support, all through the crystal-clear medium of their FM communications. German signals intelligence units, listening in, intercepted these American transmissions and noted with alarm their exceptional clarity and the sophisticated level of coordination they enabled. The intelligence section of the 10th Panzer Division filed a report stating that American units were maintaining flawless communication at ranges where their own German radios produced nothing but an impenetrable hiss of static. Even more unsettling was the dawning realization that every American tank, not just designated command vehicles, seemed capable of full powerful transmission. The German FUG-5 radios operating on amplitude modulation in the 27.0 to 33.3 octave-hertz band were plagued by fundamental, insurmountable limitations. Their 10-watt transmitters struggled to push a signal 2 to 3 kilometers, even under ideal static conditions, a range that shrank to mere hundreds of meters once the vehicles were moving. Every spark plug firing, every electric motor turning, every metallic clatter of the tracks generated a storm of electromagnetic interference that the AM systems were simply incapable of filtering out. September of 1943 saw American armor grinding its way into Italy, where the rugged mountainous terrain should have neutralized any radio advantage. Instead, the opposite occurred. FM technology proved to be even more indispensable in conditions that rendered the German AM radios completely and utterly useless. The SCR-508's frequency modulation gracefully handled the multipath interference created by the echoing mountain valleys, a phenomenon that completely garbled amplitude modulation signals. American tanks coordinated their movements through landscapes where visual signals were a physical impossibility, and German radios failed entirely. During the relentless advance toward Cassino, American armored units displayed capabilities that simply defied German military comprehension. Tank platoons, separated by towering ridgelines, executed perfectly synchronized attacks with a precision that German doctrine insisted could only be achieved through direct visual contact. The after-action reports from the 1st Armored Division routinely described seamless coordination at distances that would have relegated German radio operators to a world of pure static. June 6, 1944. As Sherman tanks churned through the surf and rolled off landing craft onto the beaches of Normandy, their SCR 508 radios kept them in constant, life-saving contact with naval fire support, a level of inter-service coordination that was simply impossible with German technology. However, the brutal close-quarters fighting in the hedgerows soon exposed a critical communication gap. The tank radios could not speak to the infantry's radios, as they operated on entirely different frequencies. The infantry's SCR 300 walkie-talkie used the 40.0 to 48.0 Morse band, making it incompatible with the tank's 20.0 to 27.9 MHz range. This chasm in communication proved deadly in the labyrinthine Bocage country, where German infantry armed with Panzer Fausts could stealthily approach American tanks while nearby GIs had no way to warn the tank crews of the imminent danger. True to form, American ingenuity solved this deadly problem within a matter of weeks. Tank crews began mounting EE-8 field telephones inside ammunition boxes, which they then welded directly onto their tanks' exteriors, wiring them straight into the internal intercom systems. By the time Operation Cobra launched in late July, this brilliantly simple field modification had completely revolutionized tank-infantry cooperation, turning the tide in the hedgerows. July 25th to 30th, 1944. Operation Cobra was a stunning showcase of the full, devastating potential of American radio superiority. The 2nd Armored Division, under the command of Major General Edward H. Brooks, masterfully coordinated over 200 Sherman tanks through intricate radio networks that provided an unprecedented level of battlefield control. The German defenders from the elite Panzer Lehr division found themselves facing an enemy that seemed to possess a kind of supernatural battlefield awareness. American tanks reacted instantaneously to threats reported by other units miles away. Artillery strikes, coordinated through the tank radio nets, rained down with pinpoint accuracy within minutes of a target being identified. The contrast with German capabilities was nothing short of shocking. Panzer Lehr, once the pride of Germany's armored forces, had been reduced to a state of communication poverty. Most of its tanks were operating without any radios at all, forced to rely on visual signals in terrain where visibility was often less than 100 meters. The few radios that were still functioning suffered from the usual crippling interference and limited range, making any effective, large-scale coordination an impossible dream. The irony of the situation was profound and tragic. It was Germany, after all, that had pioneered the use of radio in armored warfare. Heinz Guderian, the very architect of the Blitzkrieg, had passionately insisted on equipping tanks with radio equipment as far back as the 1920s. His influential book, Achtung Panzer, he published in 1937, repeatedly emphasized that communication was the absolute cornerstone of successful armored operations. Guderian had personally overseen the development of radio communication systems that allowed tank officers to coordinate their attacks on the move. He understood, perhaps better than anyone, that rapid, deep armored advances required flawlessly reliable communication. Yet, by 1943, Germany's own strained industrial production could no longer supply the very radios that Guderian's own doctrine demanded. German production statistics from that year tell a grim story of the escalating crisis. In 1943, Germany managed to manufacture approximately 5,700 medium tanks, but fewer than 2,000 FUG-5 transceivers rolled off the production lines. Many of these precious radios were prioritized for command vehicles and assault guns, leaving the regular tank units desperately short of essential communication equipment. Soviet tank forces, meanwhile, suffered from an even more extreme form of communication poverty. The legendary T-34, despite being the most produced Allied tank of the war, typically rumbled into combat with no radio equipment at all. Soviet doctrine relied heavily on primitive flag signals and rigid pre-battle planning, a system that had led to catastrophic results against the well-coordinated German forces in 1941. By 1943, the Lend-Lease program had provided some measure of relief. American radios, including SCR 508 sets, began to appear in Soviet command tanks. But even by the war's end, it is estimated that only about 25% of all Soviet tanks carried radios of any kind. This stark comparison powerfully highlights the sheer scale of the American achievement. While the Soviet Union struggled to equip even a quarter of its tank fleet with any radio, America had successfully achieved a 100% deployment rate of highly sophisticated, state-of-the-art FM systems. Motorola's Chicago factory stood as a testament to American industrial mobilization at its absolute zenith. Before the war, the company had been a manufacturer of car radios. The pivot to military production demanded a complete retooling of its facilities and the solving of unprecedented technical hurdles. Each individual SCR 508 radio set required an astounding 2,148 individual components, all manufactured to incredibly exacting military standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Its crystal oscillators had to maintain perfect frequency stability, despite enduring the wild temperature extremes and the violent, bone-jarring vibrations of combat. The production statistics alone narrate the epic tale of American industrial might. Through the 800 SCR 508 family radios produced in 1943, soaring to 11,400 units in 1944, with a total wartime production of over 50,000 complete tank radio sets. This production miracle ensured that every single one of the 49,324 Sherman tanks manufactured during the war was equipped with this sophisticated radio gear, an accomplishment that no other nation on Earth could even begin to approach. The advantages of the SCR 508 extended far beyond its use of frequency modulation. Its crystal-controlled frequency stability meant that tank crews could preset their channels before entering a battle and trust them to remain perfectly aligned despite the chaos and jarring impacts of combat. In contrast, the German Fuji-5 radios, which used variable capacitor tuning, were constantly drifting off frequency, requiring frequent and frustrating readjustments. The dual receiver configuration was a commander's dream, allowing him to simultaneously monitor both his local platoon net and the broader company command net. This meant that orders flowed down the chain of command instantaneously, while the commander could maintain a constant, real-time awareness of the situation facing his subordinate units. The BC-606 intercom system was seamlessly integrated with the radio, enabling any crew member to instantly alert the commander to a newly spotted threat. Specialized throat microphones and noise-canceling headphones ensured crystal-clear communication even in the deafening interior of a tank in battle. Shockingly, many German tanks lacked intercoms entirely, forcing crews to resort to communicating by shouting or through a crude system of physical taps and shoves. Power management was yet another area where the Americans held a distinct advantage. The SCR 508 was cleverly designed to operate on either 12 or 24 volts, automatically adjusting to the available power source. A dedicated dynamotor power supply provided a stable, filtered current that eliminated electrical interference. German radios, on the other hand, were powered directly from the vehicle's electrical system, meaning they picked up every spark from the engine as another crackle of static. The tactical advantages conferred by this universal deployment of superior radios completely transformed American armored doctrine. It gave birth to the combat command structure, highly flexible combined arms task forces that were organized for specific missions and depended entirely on reliable, ubiquitous communications. American commanders could now create ad hoc battle groups on the fly, pulling units from different parent formations, confident in the knowledge that they could all coordinate seamlessly through their compatible radio systems. This level of adaptability consistently baffled German commanders, who were accustomed to the rigid organizational structures necessitated by their own limited communication capabilities. During the fierce Battle of Ericourt in September 1944, the 4th Armored Division found itself pitted against multiple German panzer brigades equipped with technologically superior Panther tanks. On paper, the Germans held every advantage in armor protection and firepower. In reality, American radio coordinations proved to be the decisive factor. Every single Sherman on the battlefield could instantly report enemy positions. Tank destroyers received precise targeting information from tanks they couldn't even see. Artillery observers, riding in Sherman command tanks, called in devastatingly accurate barrages that arrived within minutes of a request. Over a period of 3 weeks, the 4th Armored destroyed an astonishing 281 German armored vehicles, while losing only 41 of their own Shermans, a staggering 7-to-1 kill ratio that completely defied the technical specifications of the vehicles involved. Throughout the entire war, German intelligence consistently failed to grasp the true significance of America's communication superiority. Their combat reports would often mention the impressive American coordination, but they almost always attributed it to superior training rather than to a technological advantage. A captured intelligence assessment from September 1944 stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely missed the revolutionary technological foundation of that coordination. German tactics, as a result, never adapted to counter these American capabilities. They continued to futilely target supposed command tanks based on their antenna configurations, never realizing that every single Sherman could direct and coordinate the battlefield response. They planned elaborate ambushes, assuming that American tanks would lose their cohesion once they were separated, never understanding that radio contact maintained that unit cohesion regardless of whether there was visual contact. March 1945. As American forces closed in on the Rhine, their communication superiority reached its absolute zenith. The dramatic capture of the Remagen Bridge stands as a powerful testament to the incredible speed of American command and control. When the 9th Armored Division discovered the Ludendorff Bridge miraculously still intact, radio reports flashed to 1st Army headquarters within minutes. Within a single hour, divisions all across the entire front were shifting their axes of advance to exploit this incredible, unexpected opportunity. The German forces, critically dependent on telephone lines that American aircraft were systematically destroying, were simply incapable of responding with anything approaching comparable speed. American radio coordination then created an impenetrable defense of the newly established bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating their fires through their shared radio networks. German counterattacks, poorly coordinated due to their own catastrophic communication failures, arrived piecemeal and were systematically destroyed in detail. April 1945. The encirclement of the Ruhr Pocket was the grand culmination of American communication superiority. American armored columns from the 1st and 9th Armies executed a complex double envelopment, a pincer movement of breathtaking scale and complexity, coordinated entirely through radio communications. Inside the tightening pocket, 325,000 German troops found themselves hopelessly trapped, partly because their entire communication infrastructure had completely collapsed. American fighter-bombers, guided by radio-equipped forward air controllers, had systematically hunted down and destroyed German communication nodes. Wehrmacht units lost all contact with their higher headquarters and eventually with each other. Field Marshal Walter Model's final desperate messages before the communication failure became total revealed the German plight. No contact with adjacent units. No communication with higher headquarters. Fighting continues, but coordination impossible. American radio superiority also had a profound, though often overlooked, effect on the psychological experience of tank warfare. American crews fought with the comforting knowledge that they were never truly alone. Even when physically isolated and surrounded by the enemy, they remained connected to their comrades through the invisible tether of radio waves. German tank crews, by contrast, experienced the opposite, a profound and terrifying isolation. Unable to communicate, they were forced to fight individual, desperate battles within the larger, confusing engagement. Otto Carius, one of Germany's most celebrated and successful tank commanders, wrote in his memoir, Tigers in the Mud, about the immense challenges posed by limited communications, though his focus remained more on the tactical aspects than on the communication gap itself. The strategic implications of this disparity extended far beyond individual battles. The incredible tempo of the American advances in 1944 and 1945 was sustained in large part by a level of radio coordination that the German forces simply could not match. The Third Army's legendary race across France, for example, depended entirely on radio networks that maintained command and control across hundreds of miles of territory. German commanders consistently and disastrously underestimated American capabilities because they could not even conceive of the communication superiority the Americans possessed. Heinz Guderian, in his later role as Inspector General of Armored Troops, eventually recognized the problem, but found himself powerless to solve it. In a memorandum dated December 1944, he explicitly acknowledged that American coordination was consistently negating the German advantages in tank quality. After Germany's surrender, American technical intelligence teams swarmed over captured German equipment. Their findings confirmed what combat experience had been suggesting all along. German tanks often possessed superior armor and armament, but their communications were catastrophically inferior. U.S. Army Technical Intelligence Report No. 176 concluded German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities. Soviet evaluators reached very similar conclusions. The Red Army, given access to captured German equipment, made the telling decision to copy American radio designs, rather than German systems, for their own post-war development. The production and deployment statistics reveal the sheer magnitude of the American achievement. American radio production, radios produced 50,000 plus units. Sherman Tanks produced 49,324 units. Radio deployment rate, 100%. Transmission power, 25 watts. Frequency stability, crystal controlled, plus Loboco 1%. Range, moving, 7 miles. Range, stationary, 10 to 15 miles. German radio production, Fu-G5 transceivers produced approximately 6,000 units. Medium-heavy tanks produced approximately 12,000 units. Full transceiver deployment rate, approximately 20%. Transmission power, 10 watts. Frequency stability variable, Bose 1%. Range, moving, 0 to 1 mile. Range, stationary, up to 3 miles. Communication effectiveness, average time for American fire mission, 3 to 5 minutes. Average time for German fire mission, 15 to 30 minutes. American tanks achieving coordination, 100%. German tanks with full communication, 20%. The radio superiority of the Sherman tanks established fundamental principles that continue to govern armored warfare to this day. Modern main battle tanks carry communication suites that can trace their lineage directly back to the SCR 508. They may be digital rather than analog, but they are fundamentally based on the same principles of universal deployment and reliable coordination. The German Bundeswehr, rebuilt in the 1950s, prioritized communications based directly on the hard-learned lessons of World War II. Every Leopard tank ever manufactured has carried a comprehensive suite of radio systems. A Bundeswehr training manual explicitly states, the defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. Modern conflicts continue to validate this crucial lesson. In the 1991 Gulf War, coalition forces with superior communications systematically destroyed Iraqi forces that were equipped with individually superior Soviet-designed tanks, but inferior radios. In 2003, American forces once again demonstrated that network-centric warfare decisively defeats platform-centric warfare. The story of the American Sherman Tanks' radio superiority represents a victory in the electromagnetic spectrum, a victory that ultimately proved more decisive than any advantage in armor or firepower. German tank crews fought their war partially blind to this unfolding revolution, discovering only when it was far too late that every Sherman tank was not just a fighting vehicle, but an active node in history's first mobile battlefield network. The SCR-508 radio transformed the M4 Sherman from a merely adequate medium tank into an integral component of a weapon system that included every other American tank on the battlefield. This transformation proved to be more decisive than any improvement in armor or firepower could ever have achieved. Every Sherman tank carried the tools of victory, not just in its 75mm gun or its sloped armor, but in the 181 pounds of radio equipment that connected its crew to every other American tank crew. This invisible connection created a collective intelligence, a shared consciousness that no individual German tank, regardless of its superiority in armor or firepower, could ever hope to match. German forces discovered this new reality through bitter, repeated experience. At Kasserine Pass in the mountains of Italy, across the hedgerows of France, and in the final, desperate battles inside Germany itself, American tanks demonstrated a level of coordination that German doctrine insisted was impossible without direct visual contact. The Wehrmacht never developed an effective countermeasure because they never fully understood the true nature of the technological gap. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender, "We knew how to build better tanks, but you knew how to make them work together," whether accurately quoted or simply apocryphal, captured a fundamental truth. America had built not just 49,124 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs that historians now identify with modern network-centric warfare actually began in 1942, the moment the first Sherman tank equipped with an SCR-508 radio entered combat. From that moment on, warfare had changed forever. The side with superior communications would now defeat the side with superior weapons. The network would defeat the platform, and the connected would inevitably overcome the isolated. This transformation occurred largely unseen by the German forces. They saw the effects of American tactical superiority, but they failed to recognize its technological foundation until it was far, far too late. By the time German commanders began to understand that every single Sherman tank possessed communication capabilities that most of their own tanks lacked, the war was, for all practical purposes, decided. The German military's failure to recognize and adapt to American communication superiority stands as one of the great intelligence failures of the Second World War, despite countless battlefield encounters that demonstrated the advantages of American coordination. The German leadership never prioritized solving their own critical communication weakness. They continued to build superior tanks that fought as isolated individual gladiators, while the American forces built adequate tanks that fought as coordinated, cohesive teams. In the end, the electromagnetic waves carried by the SCR-5G8 radios proved to be more powerful than the armor-piercing rounds fired by the feared German 80mm guns. The ability to coordinate, to share information instantly, to fight as a unified force rather than as a collection of individual vehicles, this invisible advantage determined victory more surely than any visible superiority in armor or armament. The Sherman tank's radio superiority changed warfare forever, establishing the immutable principle that in modern combat, connection equals survival, and isolation equals defeat. German troops discovered this harsh reality on battlefields across 3 continents, learning too late that the Americans possessed not just numerical superiority, but a profound technological superiority in the one dimension that mattered most: the ability to fight as one.